Okay, so where we're at with Artifact is a breakthrough and the pain that comes with that.
Okay.
I
Sounds good
have,
and bad at the same
yeah,
time.
yeah, yeah, yeah. So one of the key aspects of a universal platform is that the data format be extremely accessible and universal. And so we chose Git because of that universality. Let me try and share the screen of mine.
Yep. Got it.
Yeah. Is universality, as I was saying. Now, Git works basically on anything that can run software. Hang on, buddy. I'll get to my point. I'm just trying to piece it together. What the difference is. When you have a Git repo, you always have that .git folder, and there's issues. The issues that arise from that is that how I was storing things in the past, I didn't know how to, like, the .git folder is outside of hash-based control, and so you can't commit it, which means that it's not portable, which means that in our system, I had to write some custom database logic that stored the information within that .git folder in our database of choice, and so immediately it's not portable. You can have everything except those bits. And so what I figured out was how to, that if I make a dedicated branch, which I named Artifact Consensus, and if I make that part of every repository that gets created or cloned, then I can, within that branch, store all the contents of the .git directory within a Git branch itself, so that if you were to clone it or copy it or download it, you would have all of that in one modular package. And why that's good is because it means that for creating the standard platform, the standard environment, there is now no data that's stored outside of the Git repo. And so the Git repo becomes this universal tile that repeats, can be arranged in hierarchical trees. And so it collapses down things like permissions, so that permissions goes in that one special branch. And so do children, like child repositories. And so making the hosting platform requires you to make a single initial repository, which is the one repository that has no children. And from then on, all your user accounts are just child repositories. Those user accounts can make their own child repositories. There's no data that isn't in a repository in that design, and that is perfect modularity.
Yep.
And so what
Totally got it.
happens?
Yeah.
So what happens is, in that one branch is also all the stucks. So it would be like putting all of your GitHub issues into that one special branch as well, so that the repo contains GitHub within it, or its features of GitHub. It contains the authentication, like the RBAC configuration to say who can access this repository and who cannot. And so the repository becomes the standard unit that can be permissioned, shared, distributed around, and that's what we can make cells out of, where it's like cells of permissions, networks.
That's perfect.
Right.
That's spot on.
That's the thing, right?
Yeah.
That's the unit.
Yeah.
That's the unit.
Yeah.
That's the unit that we haven't been we've been chasing that for a very long time, but that's the unit. So that's what I've been working on. It works out technically. It's just been a little bit tricky to get that loop going, because the issue that's holding me up is when you first make the repo, you've got no commit, and yet you're trying to make this branch that is a commit, and it's rather convoluted. But I'll get it. And
what's the is there a concept of cascading permissions?
Yeah, there was.
So
I
got,
called
say,
yeah. So you got this parent that made a child, and the child, in some cases, the child may continue to be owned by the parent, and in which case it could point its permissions to the parent. So if you've got permission to do something to the parent, then so you don't have to go around configuring everything all the time.
Yeah, that's perfect. That's
but
really good, actually.
Look, I don't know exactly how that's all going to play out. We got to do it and roll it around a couple of times, but the roles seem pretty simple. It's just like, can I read? Can I write? Am I the owner? Am I a shared owner? Do I need to participate in consensus? All that. And so in that special branch also goes the consensus configuration of the repo. So you're like, well, these are the keys of the 5 hosts that run this repo, for example. And so all these features that we've talked about, all that metadata, all that sort of what used to be kind of outside data, is in that one branch. Now, the final piece of that, I can see that you appreciate the benefits of that just by what I've explained. But the real benefit architecturally or technically to me is that now for any given repo, because what I'm doing is in that one branch, I'm storing all the latest commits of all the branches that might be occurring within that repo. What that means is that the state of the entire repo can be expressed as a single hash. A single commit gives you a guaranteed view of the state of every branch across the repo, no matter how big it is. And that's something that we'd lacked before, because that's not how Git is designed. But with this modification, this single hash represents the whole thing, as many branches as you want. So that's what's going on.
Branches all the way down, and it's all on chain.
Yeah, all on chain.
Yeah, and that mirrors the way our friends are working anyway.
Yeah, anyway, because it's nature. It's just nature. It's very natural.
Yeah.
The final technical detail is that I've managed to do all that using just one database type, which is Tigris. And so Tigris has some consistency guarantees that they offer, and I've been able to take advantage of that in this model, so that now we're running effectively on just a massive bucket, like a big S3 bucket. So that's very much simple, very high performance.
And geolocated. Presumably we can
local.
Say you can only be in Europe. You can only be in
Yeah, you can geolock it. You can geolock it, but you can also move where the leader is based on your performance. Like, you might start working on a repo over my nighttime, and then in the morning, as soon as I start hitting it, it'll move over to New Zealand, and it'll be centered or located in New Zealand. Just because that's how things work now. And Fly.io, another great Another great service for us. Yeah, things are looking. It's looking like the finish line is in sight.
Okay, cool. So what's left to do before we get a portal up of some sort that we can get people to use?
I have to complete this branch thing, which I think is maybe another half day. And then I have to connect up the
Okay.
user accounts, which again, it's probably it could be as soon as the end of the week. But most likely it'll be anywhere between end of the week and maybe another week and a half. Worst case, it's I'm sorry, it's hard to tell, but it's at the level of detail now where it's just like there's not a lot to do. There's just a lot of little tiny bits. There's nothing.
Yeah.
You know what I mean? Like,
There's
it's
no
not
like
like I don't know how to do this thing.
yeah,
It's like, no, I get this thing up and then we're running. So, Flutter.io, it's all deploying, it's all running nicely. I'm feeling very comfortable with that service. Privy for the authentication, that works. That's pretty nice. Sending browser control of a repo and interaction with it, that's pretty nice. Running naps. So far I've only run internal naps, but it seems not terribly hard to run others. Yeah, it's hard to say because we can have a portal up, but it's probably going to be like, here's a portal, and then there'll be like a few stumbling blocks for them to figure out, and we'll have to react to, I think.
yeah, yeah. No, that's absolutely fine. What they're really struggling with is any kind of central base of intel and information that they trust is not going to be compromised, not only externally but also internally because they're quite compartmentalized.
Mm.
So,
So this
um,
fits
yeah,
well.
as soon as we get that, yeah, fits
All
perfect.
right. Oh yeah. So additionally, with the permissions, I spotted a way to treat the permissions like a friends list as well. So you can be in there and have your
Mhm.
own personal repo, the repo that represents you, and then you can be connected to via permissions friends. And so you can have a friends list. And so you can have a friends feed, like a Facebook feed, where you can see all the things that have occurred from all the friends that you're connected to in this
Mhm.
system. So it's basically like Facebook, but for whatever it is we're doing now.
Mm. Okay, and presumably there is some um, hierarchy there in that there is an owner of that friends list that can kick people off
Well,
at
it's only
people,
you. It's a,
that
you
sort of thing.
you own it, and we could set up things like like a whitelist. So like one particular, you could make like a KYC style service where that service exists to basically anoint people as past verification. You could
Mhm.
do it in a self-sovereign way where you can spend credits or anoint people that you know and be like, well, even just by the fact that they're my friends means that I trust them to a certain degree. And so that counts for something. Um,
Mhm.
it's basically
Okay,
decentralized friends.
right, right. So, say if there is someone wanting to set up a project for their company,
Yep.
person sets it up, it's their friends list, they invite them on, they can kick them off.
Yep.
But also they can uh, include everyone in the company at the top level,
Yep.
and then each branch, sorry, each child, as we go down,
Yep.
there are fewer and fewer people
Yep.
as required.
Yep.
Brilliant.
Yep. Plus, you
That's
can
good.
have
That's good. That's good.
you'll be able to deploy agents into each repo, so you can even start to do centralized standards without centralized data. So long as you centrally publish the agent, then the agent can say, yes, this repo is in adherence, even though you can't see everything inside that repo, but you can trust that the agent executed correctly, things like that. So there's a lot of potential here.
Yeah.
But I think this is the data structure that we have searched for, and I think that it is so far I find no fault with this model.
Okay. Well, everything you've said, it rings true. I can't find fault in that.
Sounds like the thing, right?
Exactly what we need. Yeah.
It sounds like the thing. Yeah. Who would have thought?
Exactly what we need.
The humble Git repository. All right. I spotted some other minor benefits or things. I don't know if you want to hear those now. Were there any further questions from your side?
No, but don't take the lack of questions as me not getting it.
Okay.
Because it's spot on. This is spot on.
Okay. Are you familiar with geometric decay?
Yes.
Here is.
Well, I say that. I am about 20 years ago. But
well, maybe your knowledge has declined some. Anyway, this is just to get a feel for it. This is just different geometric decay curves under different rates. Just to refresh your memory with the picture painting 1,000 words and whatnot.
It's like an inverse exponential, and the geometric decay, it has to do with the halving time, effectively.
Yeah. So I also commissioned a small spot of research, which was to go out and find, you know how there's Moore's law. It turns out there's also a corresponding one called Kreider's law. And Kreider's law is Moore's law for storage. And that too has been pretty accurate.
I've heard of that. Yeah. Give me 2 seconds. I'm just going to read what's there.
It doesn't really matter.
Yeah, I've heard of that.
But all I'm really pointing at here is that this is basically the last 10 years of cloud storage rates, and the projection.
It's to do with the amount and sorry to interrupt, just to check my memory. It's to do with size and I/O rates, and the pinning that against cost.
Yeah. So it was really just a price per gigabyte thing. So to take that research, what I'm trying to get, the point I'm trying to make is that there is, it would appear, so this my presentations, they ain't great, but you know, they do get the point across here. This formula is what you use for, you pick a redundancy factor. So like the graph I'm about to show you says that the data is stored 3 times. A lifetime factor, which is like you expect the drive to last, you know, nominally 5 years. And alpha is the rate of decay, which is to say how much the price per gig goes down every year. And if you pick,
sorry, go ahead.
No, go on.
Questions to the end.
No, go on. Question better now.
You mentioned a drive. I would assume that by drive there is effectively a SAN, which we're not looking at single drives here. We're looking at a storage service, which
it's more like
to last as long as the service.
It was more looking at the ability to store on consumer hard drives that are splattered about the place, and trying to make it.
All right. Okay.
Because part
All
of
right.
what,
So,
I keep going on about this marketplace of computing resources, right? Part of that is storage. And to be able to have an S3-like storage capability that was actually decentralized, private, and encrypted within that private realm is an important part of the computing marketplace. A serverless battlefield, one where the actual functioning computational machinery is spread about through all the equipment. I mean, what's an extra hard drive in a tank or in a in the bunker of a unit? Like an extra drive doesn't add that much, but when you sprinkle them around the place and you have this managed redundancy going on, you can get better reliability, better edge latency, particularly in wartime where the network is often down or expensive, and excellent survivability, and on top of that, I suspect, better cost even than an Amazon style storage service. So that's
yes.
the grounding of this.
Yeah. So it's not so much mean time between failure, but one unit may drop off, may drop back in,
Right.
may be destroyed.
Yeah,
But
the
the data is not
owl
lost
the
because
owl for
it's
lifetime was just saying, how long roughly speaking could you expect one unit to last, where there's enough units that it's all averaged out.
yes.
Yep. All right.
Gotcha.
Yep.
Yeah,
And
makes sense.
so when you take these simple equations, to take the most dominant feature is this one, like how much you expect the price to fall per year. Now, if we were to say that 15% price per year carried on, which is unreasonably high, but just for argument's sake, whatever,
That is quite high.
the drive lifespan was roughly 5 years, and the redundancy factor for the data we wanted to store was 3, then that means that if you take the current cost of the hardware in terms of per gigabyte storage and you multiplied it by a mere 5.4 times, then because of the geometric decay formula, that means that you could cover the cost of storing the data infinitely for a mere 5.4 times the spot price. And what
I see where you're going with this.
right, what I'm going towards. Sorry, carry on.
Yeah.
Go
on.
Go.
Sorry.
You.
Sorry, another question. How susceptible is this equation to changes in the assumptions? Like reduce 5 to 3 for lifespan, for example. Does it
well,
vary massively? Or
yes and no. Lifespan is kind of always around about that anyway. Like, no one sells hard drives that last for 6 months. Like, no one would buy them,
unless someone's dropping drones on you.
Yeah.
That's the thing.
Yeah, but this curve shows different ratios of alpha, which is your expected decay rate, and that's the dominant term. So if I expect a decay rate of
storage cost, annual decay.
So here's a sort of a good one.
Your graph.
Oh, yeah.
What's the x-axis there?
The x is poorly numbered, but the x-axis shows the see, the bold number coming up is this represents 9%, so that's a 9% decay in price. And as you can see, like if you go 7%, 6%, the inflection point sits around 3%. So at at a 3% decay rate per year, you need to charge 20 times the spot price.
Yep. Yep.
Yeah.
Yeah.
Yeah. And
Which,
so now
yep.
I know what
Yep.
you're going to
Makes
ask is
sense.
you're like, well, how reliable are these assumptions? Like, well, the past 40 years, whatever, that's been pretty good. But there's another aspect to the model where if you say that the storage prices are forever, but it also costs you to read, then you can start to make up for any shift in this formula by the pricing of the reads. So you can say that the data is you pay that amount and the data is going to be stored forever. And here's the formula that backs it up. And there's some checks that go in there and all that. But additionally, when you want to read it, it's going to cost you. And additionally, if someone else reads your data, it's going to cost them and you're going to earn something from it.
Which is remarkably like AWS. It's very cheap to write, but it's expensive to read if you go into deep storage, which is the forever
Yeah.
storage.
So, what am I getting at here? I'm saying that there's we need to present this computational marketplace, and how you structure the pricing is critical because that determines a lot of the politics around what it is that you're offering. And so the concept of forever storage, like you pay once and it's forever, and then if you delete it early you get a refund, like those are great economics. And this graph is, and this formula is to show that actually it uh it works. I think forever storage, because of the geometric decay, it's okay. It works.
Yeah, I think you're right. Could you share that chat with me
Sure.
just after?
You
Just
know
leave you now. But yes, yeah, I think your reasoning is right. And um, it's also mirrored by uh, likes of AWS and very large storage providers. The lifespan um, can be offset by the right. Say, no. Give me
Now,
a second.
yeah, why that's good is not just in wartime. Like, the price matters a lot less in wartime. It's not something that gets considered a lot. But when you look at Africa, Africa has 18% of the world's population, but less than 1% of the total global data center capacity. They also, because they skipped laying fiber and cable everywhere, they're still on cell. So the data connectivity isn't so great. And so a type of a decentralized, where, like a data center is now a village, and it's sort of all the hardware is spread out amongst different villagers. Like, that's a better deployment model than a data center model, because I don't think you're going to get data centers cropping up in Africa. It's just not really a thing. But everyone will have computing in the home, in the village, in the town. And so selling the excess capacity in a meaningful way to your peers is the future, I think.
I agree, and also remember that although it's only 18% of the world's population, it's growing faster than any other place in the world right
It's the
now.
place to be. It's the
And
place to be.
if you add in satellite datacoms
Yeah.
instead of having to dig holes,
Yeah.
then they'll do what they did with Cell, which was there's no copper landlines; they
Mm.
just leapfrogged it.
Mm.
I think they're going to be leapfrogging it to satellite data.
Mm. Mm. Yeah, so that's all
Very
I had.
fast, actually.
That's all I had.
Okay, that's really interesting. Um, Yeah,
I'll stop. So I
I
stop the
might play
recording.
around
We'll
with
move on to our other
some.
points of business.
Yeah, sure.